conversation in this section is about polynomial functions. So what we're going to do is basically look at some of the properties and characteristics of polynomial functions. We're going to look at the graph and basically give a reason for the picture that we see in those graphs. Okay, let's start out by finding the zeros. So I have a polynomial already displayed here. I'm actually going to shrink this down a little bit. So I have a polynomial already displayed here, and it's already factored out, so we don't have to worry about factoring. And I just want to find the zeros. Now, if I'm looking for the zeros, all you have to do to find the zeros is set each one of these parentheses equal to 0 and solve for x. That's all you have to do. If I take x plus 2 and say it's equal to 0, if I go through and solve for x, I get x is equal to -2. So that's one of my zeros right there. Let's take x plus 1 and set it equal to 0. Now, you don't have to worry about the power, because I know some of you are probably looking at that square. You don't have to worry about that, right? Because x plus 1 squared is the same thing as saying x plus 1, right? And if I set each one of those equal to 0, I still get -1 for both of them. So you don't have to set both of them equal to 0. That's why you don't have to worry about the power. So just set the stuff inside the parentheses equal to 0. And then you go through and you solve for x. You get x is equal to -1. That is another one of your zeros. And then the last parenthesis, x minus 1, I set that equal to 0. You can ignore the power here. You don't have to worry about that right now. And then let's solve for x. We get x is equal to 1. So my zeros for this polynomial is going to be -2, -1, and 1. And remember, when you find zeros, it's basically telling you if you graph it, if you put it on the XY plane, it's going to touch or go through one or all of these points. So I'm going to go to my graphing calculator, and to save some time, let me turn my calculator on. So I turn my calculator on, and you go to y equals. Now, if you put that polynomial that I was just working with in your graphing calculator exactly how it looks, if you look on here, I have it written exactly how it's written with the parentheses, the exponents, everything. So I have it in there, and then if I press the graph button, it looks like this. I'm going to zoom in a little bit, so I'm going to press the zoom button, and let's do Z decimal. That helps us zoom in a little bit. It makes your axis go from -5 to 5. And yeah, that's a better picture. So if you look at that picture and think about the zeros that we found, right? We found -2, -1, and 1. If you look at -2 on your graph, yes, your graph goes through -2. If you look at -1, which is right here, yes, your graph touches right there at -1. And then if you look at +1, it goes through that point. So the zeros are basically telling you their zeros are equivalent to saying x-intercepts, right? X-intercepts and zeros are kind of like the same thing. So that is how you find your zeros. Now let's go back to these powers, because I said ignore the powers for right now. So that's how you find the zeros. Set each one of your parentheses equal to 0 and solve for x. Now let's take a look at the power. If you notice on each one of these, I'm going to change color here. Let's make this red. If you notice, there is a power attached to each one of these. This one has a 3. This one has a 2. This one doesn't have anything, but if you don't see anything there, you know that it's going to be a 1. So it basically has a power of 1. If you add up all of these powers, 1 plus 2 plus 3, what you get is the degree of the polynomial. The degree is going to be adding up all your exponents. So you have 1 plus 2 plus 3. If you take 1, 2, and 3, you're going to end up getting 6. So the degree of this polynomial is going to be 6. Okay, that is how you find the degree of a polynomial. You add up all of the exponents, okay? And that's only if it's factored out the way that it is right now. So, and I'll show you the difference between that. So if you add up all the exponents, you get the degree of the polynomial. So we know how to find the zeros. We know how to find the degree of the polynomial. Let's take a look at the exponents again, because there's something else I could say about the exponents. I'm going to change colors here. Let's change to, I don't know, green, I guess. Yeah. Okay, let's do green. So another thing that we can talk about with these powers is whatever power is attached to a factor, like this x plus 2 had a power of basically 1, okay? Because it has a power of 1 in mathematics, we say that it has a multiplicity of 1. So this is a new word here, multiplicity. It's basically telling you what the power is of that factor. So like on the next one, it was x plus 1, and then the power was 2. That's basically telling you that you have a multiplicity of 2. And then the last one had a degree, or not degree, a power of 3. And the multiplicity would be 3. Okay? And what that multiplicity means is it's telling you basically if it goes through or it actually touches at the actual 0. So if I have x plus 2, we found out if you set x plus 2 equal to 0, we got x was equal to negative 2, right? Remember that when we were finding the zeros, right? Up here. Okay, if you set x plus, and I hate the way I wrote this x, so I'm going to rewrite it. And that gives you time to think also. So if I do x plus 2 and I set it equal to 0, I got x is equal to negative 2. It's basically saying that the multiplicity is going to be 1 at x equals negative 2. Okay? If it is a odd multiplicity, like multiplicity 1 is an odd number, it's basically saying that your graph is going to go through that number. So if you go back and look at the picture, and I know this is kind of weird, let's go back and look at the picture to make this make sense here. Let me turn my graph on. Let's go to x equals negative 2 right here. At x equals negative 2, my graph actually goes through that value, negative 2, because the multiplicity is 1 and 1 is an odd number. Okay, let's move on to the next one. You're going to see a pattern here in a minute. So let's say on the second one we had x plus 1 squared. So we said the multiplicity was 2. And remember, if you go back up to where we found the zeros, if you take x plus 1 and set it equal to 0 and then solve for x, we get x is equal to negative 1. Right? That was one of our zeros that we found at the very beginning. So I can say the multiplicity, and I'm abbreviating multiplicity because I don't want to write it all out. The multiplicity of that value is going to be 2, okay? Because the power is 2. So the multiplicity at x equals negative 1 is going to be 2. Now, what does that mean for your picture? Let's go back to the picture. Let's go to x equals negative 1. At x equals negative 1, notice the graph, it doesn't go through negative 1. It actually just touches right there at negative 1. You see that? That is because your multiplicity is even. It's an even number. 2 is an even number. So multiplicity is 2, which is an even number. That means it's just going to touch at that value. Okay? Okay. Let's go to the next one. So the next one is x minus 1 is equal to 0. And remember, when we solved it earlier, when we solved for x, we got x was equal to 1, which is one of my zeros. And the power that is connected to x minus 1 is 3, so the multiplicity is going to be 3. And 3 is a odd number, right? So since 3 is an odd number, the prediction is that at that value, x equals 1, it's going to go through. Let's go back to our picture. Look at your picture. Look at where x is equal to 1. It goes through that value, okay? And that is what the multiplicity tells you. If it's an odd multiplicity, it's going to go through. If it's even, it's just going to touch, right? So let's start over. Let's start all the way over with a new problem, right? I'm going to minimize this, and I got a bunch of stuff going on, and I have some problems over here on the side. I'm going to move this over here. Technology, right? Okay, so let's try this again. Okay, here's my new polynomial, right? Let me fix my scarf and focus. So I have a new polynomial here. So first, let's find our zeros, right? Let's do that in black. Let's find the zeros. Okay, to find the zeros, just set each one of your parentheses equal to 0. So I take 2x plus 1, and I say it's equal to 0, right? And I got to go through and solve for x. So if I go through and solve for x, I subtract the 1. Then I divide by 2. And I get x is equal to negative 1/2. So x is equal to negative 1/2. Let's look at the next parenthesis. X minus 3, I don't care about the exponent for right now. I just want to figure out what the zeros are going to be. So I set the parenthesis equal to 0. I go through and I solve. I get x is equal to 3. So my two zeros is x is equal to negative 1/2 and x is equal to 3. So what does that tell you about the picture? Before we even put in our graphing calculator, that tells us that if we put this polynomial into our graphing calculator, the graph is going to go through or touch at negative 1/2. It's going to go through it or touch at 3. Those two values, the negative 1/2 and 3, is the graph is going to touch or go through those 2 points. So let's take a look because they're x-intercepts. Let's put this in our graphing calculator. I don't have this in here, so I have to, let's clear this out. Let's put 2x plus 1, and then what was it, x minus 3? Okay, x minus 3, no, minus 3. And it's raised to what power? Second power. Okay, so let's graph this and see what it looks like. Okay, I'm going to zoom out a little bit. So I'm going to press the zoom button and go down to Z standard. Okay, so this is what the picture looks like. So if you look at, I'm actually going to go back in. That's okay. I have a right to change my mind, right? So if you look right here at x equals negative 1/2, you see the graph goes through right here. And if you look at x equals 3, it touches right here. So keep those things in mind, right? We talked about that earlier. Let's keep those in mind. So let's change color here. Let's make this, what do we do, red? Let's do red for the degree. Now, how do we find the degree? You find the degree by adding up the exponents. So if I look up here at the top, I have a degree here of 2. And then I have a degree here. I just can't see it. The degree here is 1. Okay? So to find the degree of the whole polynomial, I got to do 1 plus 2. The degree of the polynomial is going to be 3. Okay? So the degree of the whole polynomial, the degree is 3. I get the degree by adding up the exponents. Now, let's talk about multiplicity. And what do we do that in green? Let's go back to green. Okay, so multiplicity. So for x equals negative 1/2, if you go back up here to the top at x equals negative 1/2, the degree of that factor was 1. If you look up here, the degree of this one, when you go back up here, the degree was 1. So the multiplicity of this value, x equals negative 1/2, is going to be 1. The multiplicity will be 1. Now let's talk about x equals 3. Now if we go back up to the top, the degree that's connected to x equals 3 was 2. Because when we went up here, one of our zeros was 3, and 3 was connected to a power of 2. So therefore, the multiplicity is going to be 2. Now, what did we say about multiplicity? If it's odd, it goes through. If it's even, let's try even again. It touches. Okay? So, if I go back, the prediction here is that at negative 1/2, it should be 1, which is odd, so it goes through. And at 3, it's even, so it touches. So I'm going to go back to my calculator. And if you look at negative 1/2, it does go through. And the reason why it goes through is because it has an odd multiplicity. The power is 1. If you look at 3, it has an even multiplicity because the power was 2. Make sense? Oh, am I getting somewhere with this? Let's try one more, okay? Let's try one more so we feel good. Let me see what else I have over here. I should pick something that has fractions. Yes, let's pick this one right here. I actually should do both of these. Let's do both. We'll do both. I think I have enough room to do both. Okay, let's take a look at this one first. So I want to do this one because it has a monomial in it. Let's see. Let's talk about the zeros first. Let me blow this up a little bit. Okay, so let's talk about the zeros. And this is where you set each one of your factors equal to 0. So I have a monomial here. I'm using a fancy word, monomial. That means you don't have 2 terms, it's just 1 term. I still need to set that equal to 0 and make sure that there's not a value of x that I can solve for. So if I take negative 2x to the third and set it equal to 0, I'm going to go through and I'll solve for x. The way that I do that is first I got to get rid of the number in the front. So I divide by negative 2. And 0 divided by negative 2 is 0. Then I need to get rid of the cube. So in order to get rid of a cube, I got to do cube root. So you do cube root of both sides. And on the left side, you get x. And on the right side, the cube root of 0 is 0. So if you have a monomial with a variable in it, it's always going to be x equals 0 when you go through and solve. So x equals 0 is actually one of our zeros. It's one of our x-intercepts. Okay, let's set the next parenthesis equal to 0. And that's going to give you, if you go through and solve, that will give you x is equal to 4. So that's one of your zeros. And then you have x plus 1. If I solve for x on this one, I get x is equal to negative 1. Okay? So 0, 4, and negative 1 are my zeros. So let me put this into graphing calculator. Be patient with me because I have to key this in. Be patient with yourself too when you're doing this, because this is not easy to put in. Let me actually move this up so I can see. Okay. I'm going to put this in exactly how I see it. I got to put negative 2. So the negative is right below your 3. So I put negative 2x to the third, parenthesis x minus 4, like literally put it in there exactly how you see it. All the parentheses and everything. Okay, so I have it in there like that. I'm going to press the graph button to see if I need to zoom in or out. I think that's perfect. Yeah, that's perfect. That's fine. So what were our numbers? Our numbers were 0, 4, and negative 1. So at 0, if you look at 0, okay, it seems to go through, okay. They also had 4. If you look at 4, 1, 2, 3, 4 is right here. It looks like it goes through here. And we should have something going on at negative 1, and I do. So if you look, all of these cross the x-axis or touch the x-axis in some kind of way. So they are x-intercepts, therefore they are zeros. So that is what I found doing the mathematics, is what I see in the picture display. So now let's talk about the degree. Let's do the degree in red. Okay, the degree is adding up all the exponents, right? So the first one has an exponent of 3. Even that monomial, I have to take the power of the monomial too, if it has a variable in it. So this one does, the exponent is 3. And then here, there's something here, you just can't see it. It's a 1. So I got to do plus 1. And then here, I also have something here. You just can't see it. It is a 1. So I have 3 plus 1 plus 1. The degree of this polynomial is 4. 3 plus 1 plus 1. The degree is going to be 5. Okay? So I added up all the exponents. I had 3 plus 1 plus 1, and I got 5. So the degree of the polynomial is going to be 5. Okay? Okay, now let's talk about multiplicity. So the multiplicity, let's do this in green. The multiplicity of x equals 0. Let's call this multiplicity. This is the multiplicity section. So the multiplicity of x equals 0, if you go back up here to where you have x equals 0 and look at the power that is associated with x equals 0, it's a power of 3. So the multiplicity is going to be 3. The reason why the multiplicity is 3 is because the power was 3. Now let's go to x equals 4. For x equals 4, look at the power associated with the factor that gave us x equals 4. If we go back up here to the top, the power is 1. So the multiplicity is going to be 1. And now lastly, let's look at x equals negative 1. If you look at the power associated with negative 1, we got multiplicity is 1 also. So what does that tell you? All of these are odd numbers, which means that the graph should actually go through each one of these numbers. And if we go back to our picture, it does. If you look at x equals 0, it goes through. If you look at x equals negative 1, it goes through. If you look at x equals 4, it goes through all of those. And it goes through because they're all odd multiplicities. All of these are odd numbers. Okay? Now, one more. It's somewhere down here. Yep, this one. Okay, one more. And this is good that we do this one also, because this one has a monomial also, but it doesn't have a variable on it. So it's important that we talk about that. Okay, now I'm gonna wait just to show you how this works. I'm gonna wait before I graph and see if the graph matches everything that we found, right? So zeros. Okay, your zeros. So you set each one of your factors equal to 0. Now, we have a 5 here in the front. If I set 5 equal to 0, that doesn't even make sense. Okay, 5 equals 0. 5 can never be equal to 0. So you really can ignore that value. Okay, if you have a number in the front and it doesn't have a variable on it, you can't solve for x. So you can just ignore the 5. Let's go to the next one. X minus 2 equals 0. If I go through and I solve for x is equal to 2. Okay, let's go to the next one. X plus 3. I get x is equal to negative 3. And let's go to the last one. X minus 1/2 is equal to 0. I go through, I add 1/2, I get x is equal to 1/2. Okay? And remember, when you're finding the zeros, you don't even have to worry about the power. You're just looking for the value of x. The x-intercepts are what you're looking for. So here are our zeros, 2, negative 3, and 1/2. Now let's talk about the degree. What color did we do the degree? We did the degree in red? Yeah. So let's talk about the degree. So the degree is adding up the exponents, okay? That 5 in the front, because that 5 did not have a variable, you can ignore it. You don't count the degree or the power that's associated with just a number. It has to be a variable involved. Let's go to the next one. So what's the power here? 1, okay? So we got 1 plus, what's the power here? 2 plus, what's the power here? 4, okay? So you take all those numbers, you add them together. 1 plus 2 plus 4. Let's see if I can add this better than the last one. 7. Okay. So the degree is 7. Okay. The degree of this polynomial is 7. And then lastly, let's talk about multiplicity. Okay. Multiplicity. So what's the multiplicity of x equals 2? It goes back to the power. Okay. The multiplicity is going to be 1 because the power was 1. Okay. What's the multiplicity of x equals negative 3? You go back up here and you look at the power. The power is 2. So the multiplicity is 2. What's the multiplicity of 1/2? Again, you go back and you look at the power. The power is 4. So the multiplicity is 4. Okay? So let's make a prediction about what we would see if we were to graph this, right? Since this multiplicity is 1, and 1 is an odd number, okay, that means that when you look at the graph, it's going to go through. Okay, because it's an odd number. Right here, this is an even number. Is right here, x equals negative 3 had a multiplicity of 2. Because this is an even number, that means it's just going to touch Okay, and then lastly, because this multiplicity is 4, that is an even number. Again, it should just touch. But I would say, okay, now that we found all this information, I challenge you to look this up in your graphing calculator and see if the information matches what you see in the graphing calculator. Okay?